Hello everyone, welcome back to Must Electronics. This is the Android 14 source code, fully downloaded and ready to build. Over 800 Git repositories, all synchronized into one directory. Hundreds of thousands of files spanning the kernel, the framework, system services, hardware interfaces, and everything in between. Getting to this point, a clean, complete sync is something a lot of people struggle with. The commands look simple, but if you get the manifest wrong, or if you do the local manifest at the wrong time, you end up with a broken or incomplete source tree. In this episode, I'll show you exactly how to do this correctly, the same steps I used to produce the working Android 14 build you saw in the previous episode. All comments are in the description below. Let's get started. Before we run any commands, you need to understand what repo actually is. Android source code is not stored in one massive Git repository. It is split across more than 800 individual Git repositories. There is a separate repository for the kernel, for the framework, for each system service, for each hardware interface, for build tools, and so on. Managing 800 Git repositories manually would be impossible. That is what Repo solves. Repo is a tool written by Google specifically to manage multi repository Android builds. It reads a manifest file, which is an XML file that lists every repository, its remote URL, its branch, where it should be placed in your local directory. Then Repo fetches all of them in parallel, keeps them in sync, and helps you manage changes across multiple repositories at once. Two commands do all of this. Repo init, which reads the manifest and configures your local workspace. Repo sync, which fetches the actual source code from every repository listed in the manifest. That is the entire workflow. Let's now do it. First, create a dedicated directory for the Android source. We are naming it AOSP-Android 14. This is to be explicit about what branch this is. If you ever work with multiple versions, this naming will save you confusion. One important note on storage. Make sure you have 350 to 400 GB free on this drive before going any further. For that, you can use df-h tilde, and here you can see the space remaining. So I have total 442 GB and used is 255 GB and available is 165 GB. I'm short of storage here. So it should be free of around 350 to 400 GB to continue further. So I'll make some space and I'll start with the repo in it. If your number looks good, let's initialize the repo workspace. I have cleared some space. Now I have enough space to continue further. I hope you also have around 350 to 400 GB on your drive. Okay then, let's start with repo in it. This command tells repo which manifest to use. In other words, which version of Android we want and where to fetch it from. Let me break this down. The -u flag is the URL of the manifest repository. This is Google's official AOSP manifest hosted on googlesource.com. The -b flag is the branch. Here we are using Android 14.0.0 R67. This is not just Android 14. It is a specific release tag. R67 means the 67th release of Android 14. The tag matters because Android 14 has received many security patches and updates. Using a specific tag gives you a reproducible build. You will always get the exact same source code every time you sync. Once repo init completes, a hidden directory called .repo has been created. The .repo directory is the control center for your workspace. Inside it, you will see manifest.xml file, which is the active manifest file that repo will use for sync. Manifest directory, a full Git repository containing all AOSP manifest files. Repo directory, the repo tool itself. Let me open manifest.xml file to show you what it looks like. Here they have included default.xml file. So let me open that. Default.xml file is inside manifest directory. This XML file lists every single repository that will be synced. Each project entry has a name, a path, and sometimes a specific version. This file is what tells Repo where to put every piece of Android source code. But we are not done yet. We need to add one more manifest for Raspberry Pi. The AOSP manifest contains everything Google ships in AOSP, but it does not include Raspberry Pi device support. For that, we use Raspberry Vanilla project, a community maintained set of repositories that add Raspberry Pi hardware support to AOSP. This is called a local manifest. A local manifest is a separate XML file you placed inside .repo local manifest directory. When repo syncs, it reads both the main manifest and all local manifests and combines them into a single unified source tree. The Raspberry Vanilla local manifest adds the Raspberry Pi device tree, the Raspberry Pi kernel, Raspberry Pi specific HAL implementations, the SD card image assembly scripts. Without this, syncing AOSP alone would give you source code that has no idea what a Raspberry Pi is. Let's add it. So we have already did repo init with the same command. Now I'll run this command. Two flags worth noting here. -L tells curl to follow redirects. GitHub URLs often redirect. So without -L, the download silently fails or gives you an HTML error page instead of XML. -create dirs automatically creates the .repo local manifest directory if it does not exist. This saves you a separate mkdir command. Let's verify it was downloaded correctly. You can see the Raspberry Pi specific repositories listed here. The kernel source for Raspberry Pi, the device tree which describes the Raspberry Pi hardware to Android, vendor specific files, and configs. These are the repositories that make this an Android build for Raspberry Pi specifically, rather than just a generic AOSP build. With both manifests in place, we are ready to sync. This is the big one. Reposing fetches the actual source code from every repository in both manifests. Over 800 repositories being cloned in parallel, roughly 250 GB of data. Depending on your internet connection, this takes anywhere from 2 hours to a full day. Here is the command. You can see it starting to go through the repositories one by one in parallel. Each line is a separate Git repository being cloned from Google server. This is going to run for several hours. Leave it running overnight if you can. Do not close the terminal or suspend the machine while it is running. If your connection drops or you accidentally close the terminal, do not worry. Just run reposing again. Repo tracks what has already been downloaded and resumes from where it stopped. You will not lose progress. Alright, that sync ran for several hours in the background. This is the complete result. The same source tree I used to produce the working Android 14 build you saw in the previous episode. This is what a fully synced Android 14 source tree looks like. Let me walk you through what is here. We covered the major directories in episode 2, but now you can see them for real. Frameworks directory, the Android application framework. Activity Manager Service, Package Manager Service, Window Manager Service, all are here. System directory, native C and C++ system components, the init process, logging, utilities, all are here. Packages directory, all Android system apps, settings, launcher, dialer, camera, all are here. Hardware directory, HAL interface definitions, camera, audio, sensor, graphics interface, all are here. Kernel directory, the Linux kernel source. This is the actual Linux kernel that Android runs on top of. Now let's look at what the Raspberry Vanilla local manifest added. The device directory contains device specific configurations. This is where the Raspberry Pi device tree was added by the local manifest. This is the entire Raspberry Pi 4 device configuration. Board config.mk. This is for hardware configuration for the Raspberry Pi 4 board. Device.mk. Device level build rules and feature flags. Without this device directory, the build system would have no idea how to configure Android for Raspberry Pi 4 hardware. Now let's check the kernel. The Raspberry Vanilla local manifest also added the Raspberry Pi kernel source. This is the specific Linux kernel version that has been patched to support Raspberry Pi 4 hardware with Android. Before we move on, let's do a quick sanity check. We can ask Repo to list all the projects it has synced. That number is how many Git repositories were synced into this directory. Each one is a self-contained Git repository. Each one has its own history, tags, and branches. You can verify a specific project is checked out on the right branch. These are the repositories added by the Raspberry Vanilla local manifest. They are part of the unified source tree now, just like any other AOSP directory. Also check the total size of what was downloaded. It's 239 GB, exactly what we warned about in episode 3. The source code is ready. To recap what we did, we created the AOSP Android 14 directory, we ran Repo Init with Google's Android 14 manifest, we added the Raspberry Vanilla local manifest for Raspberry Pi support, and we ran Repo Sync to pull down all 800 plus repositories. One source tree, two manifests, one command. That is all it takes. In the next episode, we start exploring the AOSP source tree in detail, the purpose of each major directory, what lives where, and how the pieces connect. This is where you stop being someone who downloaded Android source code and start being someone who actually understands it. If this was helpful, please like the video and subscribe to Must Electronics.